Today's lesson, we're going to talk about permutations and combinations from the probabilities. So before we go into the permutation combinations, let's talk about factorial. This is read as the factorial in math. What does the factorial means? Factorial means that you're going to multiply a number from 1 to the given numbers. So for example, if you have 3 factorial, this means you're going to multiply from 1 to all the way to 3, right? Or if you have a 5 factorial, means you're going to multiply from 1 all the way to 5. All the number from 1 to all the way to 5, right? That's the factorial means. So by the definition, if we have a 0 factorial, it starts multiplying from the 1, so that's going to be 1. So 0 factorial is equals to 1. That's something you need to remember it. And this is what factorial means, right? And we have permutations here and their definitions, and combination here with the definitions. But bottom line is permutation, you use it when the order is matter, and combinations, you use it when order is not matter. And here is the formula for the permutations and formula for the combinations. So what's those letters stand for? So the N, so P is for the permutations, but N is the total number of the objects in a set, so total numbers. R is the number of choosing objects from the set. So let's say you have 5 and you're picking 3, right? So 3 is going to be R and 5 is going to be N. Same thing for the variables for the combination formulas. And you will understand better when we're going to look at the examples. First example, I wanted to look at what's the 5 factorial. I gave you the example for it, right? 5 factorial means you're multiplying 1 all the way to 5, right? And most of the times you start with the number and go down all the way, right? So start from the given number and multiply all the way. And this gives you 120. So 5 factorial is equal to 120. What about if you have a factorial but fraction form of it? Well, this is going to be same as 7 factorial is multiplying starting from 7 and all the way to 1. And 6 factorial is starting from 6, multiply all the way to 1, right? So if you have this order of the factorial, that cancels out and just give you 7, right? So 7 factorial over 6 factorial cancels out everything that's below 6 and just give you 7 by itself. So that means this one right here, everything that's below the 5 will cancel out by the 5 factorial. So on the numerator, you will only have 8 times 7 times 6 remaining. So that will give you 336. Right? So again, if I wanted to write it in the middle step right here, it starts from 8 times 7 times 6 times 5 factorial, and then you had a 5 factorial, so 5 factorial cancels out and you end up getting 876 remains to multiply. That's how you get 336. So then if you have 2 factorial on the bottom, what I will do is I will get rid of the larger factorial first. So it means 52 factorial. You only need to multiply all the way to 78 because 47 factorial will cancel out the numerator, right? So I will only have 51 times 50 times 49 times 48 remains because 47 factorial after that will be cancel out by the 47 factorial. And then you have 5 factorial on denominator, which is going to be 5 times 4 times 3 times 2 times 1. So you could use a calculator to do that, or reduce. So 5 goes into 50 10 times. 4 goes into 48 12 times. Look like 2 goes into 10 5 times. 3 goes into 12 4 times. So basically, denominator will be 1. And numerator will be 52 times 51 times 5 times 49 times 4, which you will end up getting a pretty large number. And you should be able to figure this one out using the calculator. So this is how you're going to use the factorial. We need to know that in order to use the permutations and combinations of formulas. Now, example 2 is asking to find the permutations from the 3 set given and taking 2 at a time. And the first time, use the tree diagrams. Second time, use the multiplication principle. And the third, we wanted to use the formula from the permutations. So if we wanted to use the tree diagrams to pick set of 3 objectives taken and 2 at a time, the first choice out of this 3 element is going to be A, B, C. That will be my first choice. And after that, you should be able to pick, because you pick A already for the first time, the second time you can either pick B or C, right? Same thing when you pick B for the first time, second time you can pick only A or C. When you pick C for the first time, second time you should be able to pick A or B. So how many times? You have set of 1, 2, 3, 4, 5, and 6. So using the Venn diagrams, you have 6 choices. What about if you're using a multiplication principle? Well, you have a 3 first time when you're picking. So 3 options. And then second time you're picking, because you already picked 1 out of 3, your choice is 2, right? So this is going to give you 6 options. So using the multiplication principle, you still get the 6 options. What about if we use the permutation formulas? So permutation is saying out of 3, you're picking 2, right? So using the formula, you're going to get n factorial, which is going to be the total, over n minus r factorial. N is going to be total minus the choice that you're picking, so it will be 2 factorial, which gives you 3 factorial over 1 factorial, which is just the 1, right? So this gives you 3 times 2 times 1 over 1, which is going to be 6 choice. So either method, you will get all 6 options. So when we're looking at example 3, and you should be able to do any method of your choice on this one. and it say permutation of 13 objective taken 8 at a time. So if I wanted to use the formula, it will be the permutation formula. The total number is 13 objects, and you're picking 8. So it will be 13 factorial over 13 minus 8 factorial. That gives you 13 factorial over 5 factorial. And when you plug in that number into the calculator, you get pretty large numbers. And that should be your options. Picking 8 from 13 objects. Let's look at example 4. Example 4 from the committee of 10. So the total number of 10. A. In how many ways can we choose a chairperson, vice chairperson, and secretary? Assume that one person cannot hold more than one positions, right? So this one, we're picking chairperson, vice chair, and secretary. Out of 10, we're picking 3 different positions, right? Here, we need to be careful because they didn't mention which formula to use it. So we have option of picking either permutations or combinations. And it say the permutation is order matter, right? Permutation used when order is matter. Combinations is when order is not matter. And when we're looking at the part A, the first person have to be chair, second is the vice president, and third secretary, right? So this time's order is going to be matter because they have a particular title for it, right? So person A becoming chair person will be different than when person A become a secretary, right? And that will be different options. So this one we will say order matter. So A, we're going to use the permutations because order is matter. Out of 10, we're picking 3. So we will have 10 factorial over 10 minus 3 factorial, which is the 7, right? This gives you 720 different ways. So when we're looking at the second one, it's saying how many ways can we choose a subcommittee of 3 people. Subcommittee of 3 people, if I have picked one person, let's call A, first, and have all other. Let's say having a A, B, C person. In that order, is that going to be different as if I pick B, C, A? Well, because it's a subcommittee, they didn't give any title for it. This is going to be the same people picking the same subcommittees. So in this case, order is not going to be matter, right? Because this is going to be same as that. So because order is not matter, we're going to use a combination here. Still, out of 10, we're picking 3. So that will be 10 factorial over 3 factorial times 10 minus 3 factorial, which is 10 factorial over 3 factorial times 7 factorial. And this gives you about 120 different ways. So that's the difference between combination and permutations. Here, if I explain a little bit better on the permutation, if I pick person A for the chair and B as the vice chair and C as secretary, will be different options if I pick C person as the chair and A person as vice chair and B as secretary, right? This is going to be called at different choices. So that's why we say the first one, order matter. And second one, order not matter. So the next example, they want you to use the combinations. So just making sure you know how to use the combination. Out of 13, you're picking 8. So that total number is 13, you're choosing 8. So that will be 13 factorial over 8 factorial times 13 minus 8 factorial. That gives you 13 factorial over 8 factorials times 5 factorial, which gives you 1,280 ways. So example 5 was just making sure you know how to use combination formulas. Now let's look at example 6, and we're going to see if we can tell if it's a permutations and combinations, and if it's a permutations or combination, let's find the ways. Example 6, it's a teacher had 5 books and wants to display 3 of them side by side on her desk. How many arrangement of 3 books are possible? It's a side by side, right? So having a A book next to B will be different than having a B book on a A, right? So this one, order is going to be matter, so we're going to use the permutations. Out of 5 book, picking 3, so that's going to be 5 factorial over 5 minus 3 factorial, which is the 2, right? 2 factorial. Gives you 60 arrangement. Here, you have another way of doing it. If you didn't want to use the formulas, the way that we did it from the previous sections, think about it, trying to draw the pictures. So you have 3 displays. So you have 1, 2, 3 books. In order to place the first book, you have 5 options. Right? But because you place 1 book, the next times your choice is just 4. And then because you already used 2 books out of 5, the third times your choice is going to be 3. So when you're multiplying 5 times 4 times 3, you will end up getting 60. So 60 arrangement is going to be the solution either way. Example 7 is asking, from 8 candidates, how many ways could voters rank their first, second, and third choices? If this problem saying that how many way of 3 choices, then order will be not matter. But if they wanted to rank it first, second, third, the order is going to be matter, because having A first, B second, C third will be different options as if I have B first and C and D as second and third. So this is going to give you different choices, different ways. So this time's order is going to be matter because the ranking is matter, even if it's the same person pick, right? So then it will be the permutations out of 8, picking 3, so it will be 8 factorial over 8 minus 3, so it will be 5 factorial. This gives you 8 times 7 times 6, which is going to be 336 ways. Let's look at number 8. So from the group of 5 students, a committee is to be chosen to meet with the dean. How many different 3-person committee are possible? So here, they just give you the number, how many people is going to be. So here, order is not going to be matter, because if I have person A, B, C, it will be the same groups of people if I have B, C, A order, right? So here, order is not going to be matter because it's just a group of 3. So then it will be the combinations. So it will be out of 5, you're picking 3 students. 5 factorial times 3 factorial times 5 minus 3 is 2 factorial. So it gives you 5 times 4 because it cancels out 3 factorials, and you had 2 times 1 remains. So it will be 10. So as you can see, combination always give you smaller values because order is not matter. Let's look at one more. Example 9, it says, in how many ways can a 12-person jury be chosen from a pool of 40 people? So this one again, picking 12. The groups of people. So because it's a group of people, order is not going to be matter. It means you're going to use the combinations. So combinations, out of 40, you're picking 12. So it'll be 40 factorial over 12 factorials times 40 minus 12, you get 28 factorial. And this gives you pretty large numbers. As you can see, you're picking 12, right? Out of 40. This is big numbers. And when you plug into the calculator, you get these numbers. Right? Okay, so now example 10. This time, you don't really actually need to solve it, but we wanted to see if it's going to be a permutations or combinations, right? So the first one, it said, in how many 4-digit numbers are possible if no digits are repeated? No digits are repeated, but 4-digit numbers. So if I have 4, 2, 1, 5, is that going to be different as 5, 1, 2, 4? The same number choice, but when number is switched, right? Switch the order. It is going to be different number, right? Even though it's the same choice of the number, because the order is different. So this means order matter, right? Order matter means is permutations. So the next example, it's a 3 light bulb is randomly selected out of 15. So 3 light bulbs. This is the groups of light bulbs, like just 3. 3 out of 15. No order. Order is not matter. So this is going to be combinations. The next one, you have 8 teams of the basketball. How many games must be played so that each team plays every other team's exactly once? So here, if I have A team play B team, is that going to be the different than if B team play A? No, this is going to be the same, right? Order, same. Even though order is different, this is going to be same pick. So it's going to be a combination on that one. The last one, in how many ways can 4 patients be assigned in 6 hospital rooms so that each patient has a private room? Well, so if I have a room 1, 2, 3, 4, and put A here, B here, C, D there is going to be different than on a 4 rooms. I put D person here and C person there, B there, A there. Is this going to be different choices? Yes, right? Having a different person in different, I mean, it's all 4, but it's different rooms, right? So order matters, so it's going to be a permutations. So once we pick, if it's a permutation or combinations, we're going to use different formulas to find the probabilities. Let's look at a few more examples. Example 11, it's a manager must select 4 employees for the promotions and 12 employees are eligible. In how many ways can 4 employees be chosen, right? So you're picking 4, groups of 4. So since you're picking groups of 4, order is not going to be better. So we know we're going to use combinations. And let's place into the combination formula. It will be 4 factorial and then 12 minus 4 factorial, right? That gives you somewhere close to 495 ways. The second one, it say, in how many ways can 4 employees be chosen to be placed in 4 different jobs? Because you have a 4 different jobs, this time order is going to be better, right? Because a person placed it into job 1 will be different than if a B person placed it in the job 1 and A in job 2, right? So this is going to call the different outcomes. So order is going to be matter. We're going to use the permutations, right? So it gives you 12 factorial over 12 minus 4, which is 8 factorial. It gives you around 11,880 different ways of picking that 4 out of 12. What about example 12? How many 5-card hands have 3 aces and 2 kings? First, we need to understand a little bit about the card. We have 5-2 cards in one deck, right? So 52 cards in one deck. And there is 4 ace and 4 king. Total of 4 ace and 4 king. And you're picking 5 cards. So when you're picking 5 cards, you're picking them in order, right? You pick one and then you pick the next one. So when you're picking, order is not going to be matter here because it's any 3 ace and 2 king, right? It didn't say the heart ace or diamond ace had to come first. They didn't mention which shape need to be coming first. They didn't mention anything about the order. So order is not going to be matter. So we're going to use the combinations. But when we're picking that 5, you don't have that 5 options. The first thing you have, let's say if we wanted to talk about ace first, you only have total of 4, and then let's say you're picking 3 out of it, right? And let's say you did that in first 3. And then next 2, you're going to pick king, right? So this is going to go by order. So you're going to do multiplications. And then out of 4 king, you're picking 2, right? So we know this is going to be combinations, and because you don't have a total of 5 for each shape, you go ace first and king seconds, and you're picking this 5 card in an order. So you're going to do the multiplication of those 2 combinations. And when you do that, you end up getting 4 factorial over 3 factorials times 4 minus 3, so it will be 1 factorial times 4 factorial over 2 factorials times 4 minus 2 is going to be another 2 factorial. This is going to give you 4 times 2 times 3 remaining, so it will be 24. Let's try one other problem with the card again. So it say you have 52 cards. How many 3 cards hands have all cards from the same suit? You have 4 different suits. And each suit will have 13 cards. So you will have 13 of hearts, 13 of diamonds, and so on, right? So you will have 4 different suits, and out of 13, you're picking 3. And they're talking about 3 cards in a group, so this is another combinations. So it will be 4 times 13 factorial over 3 factorials times 13 minus 3, so that gives you 10 factorial, which is 4 times 286. It gives you 1,144 ways.